Welcome to our next presentation, which will be about Open Sovereign Cloud. It is a large cloud platform that we are developing in Deutsche Telekom and T-Systems. My name is Vančo. I am a product owner of one of the parts of this large project, one of the teams, which is kind of middle layer of this entire platform. And yeah, I will be explaining what this is project about and how it can be useful for developers, or why it's interesting for developers, or how it's innovative in some way. Okay, first of all, some motivation why this project was launched, or what is this about, why it is called open and why it is called sovereign. Yeah, open, it's quite simple because it's, you know, designed out of the existing open source components. So that's why it is open. You can find source code of every component inside this cloud platform on the internet, on the GitHub, or in other public repositories. Yeah, so that's why it's open, and we are just simply using only open source code here. And why it's sovereign, you know, this is a little bit more complicated, so let me explain it a little bit for you. There is an organization founded by European Commission called Gaia-X. This organization is designing principles, rules, and also maybe forcing some interoperability and federation of the cloud platforms, which will follow all of the European Union laws and principles, and will provide us possibility for interoperability between multiple possible providers of these sovereign clouds. So it means that there might be more companies, either private or public, providing this kind of cloud services, and it doesn't matter for your application which cloud you will choose to use. You have freedom of choice, and every cloud will have the same principles and same interoperability, so you will be able to integrate your data layers, you will be able to move your data from one cloud to another, you will be able to integrate it into one unique system, or you can either use one cloud as primary and another cloud as a secondary or backup solution. Yeah. So all of these scenarios should be covered, and this organization is, you know, just creating framework to allow this possibility for everyone. Yeah. And we in Deutsche Telekom, we are also building this kind of cloud, which is open, which is sovereign. It means that we also have data and operational sovereignty, as I can show on another slide. And there is an interesting comparison against current major offerings in a commercial world, like Azure, Google Cloud Platform, or Amazon Web Services, because these services are entirely dependent on each particular company or some kind of provider. They are not very well compatible, so you have to design your application to be compatible with each particular cloud. Maybe you have to do a specific changes or specific support for these kind of clouds. Yeah. There is no GDPR compliance built in by default, so you have to take care about it somehow yourself, and there might be even possibility that you will be never fully compliant. And of course, it's not also compliant with European law. It means that it can be based outside of the European Union territory, or employees of these companies might be from another countries. So you cannot force, or you cannot be sure that somebody is not looking into your data because they are following laws of another countries outside of European Union. Yeah? So this is the motivation why it's like this, and why we are designing this kind of sovereign cloud. Yeah? It means that we should have data sovereignty and we should have operational sovereignty. So we have to be sure that it's running on European land and it's operated by European companies and by European employees, handled by European employees. Yeah? So that's basically the idea. And our stack, this open sovereign cloud, has three large layers. One is infrastructure layers, which is based on a technology called Metal. Yeah, I will explain a little bit more about it later. Second layer is Gardener, which is part of the platform as a service layer, and it's providing basically Kubernetes as a service, yeah, for multiple customers, or each customer can have multiple Kubernetes clusters for various applications or application environments. And third layer is software as a service layer, or service layer generally, which contains many of cool additional software on top of the Kubernetes cluster, and creates entire application environment, including service catalog and some ready-made services which can be very quickly and easily used as a ready-made components like Lego bricks for your own application. Yeah. And this third layer, it's based on an application called Kyma, and on top of this application we are also building ready-made services, for example PostgreSQL and Kafka and many others which are integral part of the Kyma distribution. For example, Redis database or many other open source components which are pretty widely known. This is a little bit more detail about what's included in each layer. So first of all, of course, we have to have some bare metal hardware and some data center, some physical and very well secured buildings where we can install all of this hardware like servers, storages, network equipment and so on. And of course there are security guys with lots of pistols and guns, yeah, securing this place, yeah. And then we have infrastructure layer, which is based on this metal technology. This is quite cool thing, so I'd like to explain a little bit more about it, because what I have known before, technologies like OpenStack or other well-known infrastructure technologies are, let's say, a little bit looking like legacy in comparison with this metal stack. This metal stack is already entirely based on Kubernetes, yeah, so it's very modern and it's cloud-native infrastructure stack. And every type of resource is basically Kubernetes object. So you can do very, very cool things with this, yeah. So this is, from my point of view, this is really a generational leap from OpenStack to this metal stack, and it's a really modern one, and also entirely based on Kubernetes internally. And of course, this infrastructure stack is offering all of the necessary basic infrastructure services like compute resources. Generally, we are talking about virtual machines here. Yeah. It's also offering storage, which is based on technology called Ceph, which is very well known. It's a distributed open source storage system. And there is also networking services, which is again very modern and very new, and it's based on Sonic operating system, which was originally developed by Microsoft for Azure internally, and then it was open sourced later. So now we can also use it in our stack. Yeah. So this is the infrastructure part, and as I already described, this second part is Kubernetes as a service, which is based on orchestrator stack called Gardener. This is again based entirely on Kubernetes. I will speak about it a little bit later, and also my colleague will have more details in his next presentation after me about this part. And the third part, as I said, is service orchestration based on software called Kyma, which contains also all of the standard observability tools, like components like Prometheus, Grafana, logging and tracing tools like Loki and Jaeger and all of these components. So you just need to have annotations in your application, and then everything will be bring up completely automatically, magically, and works all together. And this Kyma also contains serverless support, functions, and API gateway. So you have also integration components where you can put all of your microservices together and orchestrate it all together. Of course, maybe I also forgot to mention service mesh, which is also a very important part. So there is also, of course, Istio in a role of service mesh, which is connecting everything together. So you've got basically everything that you would expect from full-blown cloud-native platform, and you have everything there. There is also service catalog. I will show also screenshot later how it looks. And you have lots of ready-made services there. Some of them are being developed by Deutsche Telekom and refined by Deutsche Telekom. So we are trying to add value there and improve lots of functionalities. And some of them, as you can see also here on this picture on the right side, some of them are sourced from Kyma distribution or from other parts of various open source projects available on the internet. Yeah, and as I already explained, this Metal infrastructure, yeah, I basically already went through it, so I will just quickly summarize it. It has everything that you will ever need from infrastructure layer. Of course, there is also REST-JSON API, which you can use to orchestrate any kind of resource here. Yeah, this is currently like standard. So you can do entirely completely automatic deployments here. You can integrate with your CI/CD pipeline very easily, and you can do entire deployment automatically. Yeah, that's it. In Gardener, I'd like to speak a little bit more about this structure of this deployment. Internally, there is always a management cluster, which is called Garden cluster. This cluster is just, let's say, service plane or management cluster for the entire environment. And thanks to this component, we are able to manage multiple Kubernetes clusters, multiple separated environments, and we can even have different Kubernetes versions on each cluster, or we can use different infrastructures on the lower level. So it can be either Metal, as I already described, but you can also integrate with another infrastructure platform. As it's shown on the picture, it can be integrated with VMware, with Azure, with Amazon or Google Cloud Platform, or even your on-premise bare metal infrastructure, which you might have. Yeah? And for managing this control plane of these clusters for this workload, we are having these seed clusters. You need to have seed cluster for every type of backend infrastructure service or for every region. So in case you need a geo-redundancy, then you should deploy separated seed clusters per each different region or data center locality. And then under this seed cluster, there are one or multiple shoot clusters, which is basically only worker nodes of the Kubernetes cluster, and inside of this shoot cluster you can finally deploy your application environment, your microservices. Yeah? So that's what you have under control, and generally you will get full administrator rights of this shoot cluster, so you can do whatever you like with your automatic CI/CD pipeline there. You can deploy applications, you can manage access rights, you can do whatever you like there. Yeah. This is a little bit complicated picture, so I will not scare you about going into so much detail. This is just for the reference if you will be wondering how it's really working inside and how complex is this environment, then you can see yourself. This is taken from public documentation which you can find on the internet. If you will look at the GitHub and find the Gardener project, then you will very quickly find it in a documentation. And here you can see what's inside these basic components, inside Garden cluster, inside seed cluster, inside shoot cluster, and how it's integrated together. Yeah? Maybe I will just mention that you have multiple interfaces to manage these clusters environment. So this is really a huge advantage. You can manage Kubernetes directly via standard tools like kubectl or Kubernetes dashboard, or you can use tools which is specific for this Gardener orchestrator like GardenCTL or Gardener dashboard. This Gardener dashboard I will show on the next slides a little bit later, so you will see yourself how it looks like. And of course, you can also do fully automatic deployments via API and with using just descriptive YAMLs, where you will just describe your deployment and your needs or requirement settings, and then just fully automatically deploy new shoot cluster or new seed cluster or every component which you will really require. And this is how this console looks like. So you can see on the animation that you can easily, via a few clicks, create entire full-blown Kubernetes cluster. Yeah, and it's created, let's say, in a few seconds, or in worst case, in some minutes. Yeah, so you can have multiple clusters, as I said, with different versions of Kubernetes. So this is really an advantage because you can really test with your application workload, how your application is behaving on maybe a little bit newer Kubernetes version before you will deploy it into production, and you can maybe catch some problems before it will went into production, and you can resolve them and then later switch into production. So you can have different environments here. You can even isolate your application development teams so they will not interfere with each other. They will not destroy things for each other. You know how it is like when developers are, playing around with some stuff on the cluster. Sometimes they are able to break it completely, yeah? So in this case, I think this is a huge advantage. You can have multiple clusters, you can isolate teams, you can isolate types of environments, you can have development environments, you can have test environments, which will be separated, and of course, this is absolute must, production environments will be separated too, yeah? And it's just few clicks to create new cluster, so it's very easy, very quick. Okay, few more words about service orchestration. This Kyma runtime, it's basically again just a Kubernetes operator and with lots of additional cool stuff. And as I said, there is also I've got some issue here. Sorry. Sorry, that was one technical issue which is already resolved, so I'm going to continue. So we've got this serverless concept here, which is again something quite cool and something that is already being used in lots of applications or in application components. We've got all of the integration stuff here. We've got service mesh here, API gateway, all of the observability tools like logging, monitoring, tracing, and of course eventing. Yeah, and this is all deployed into basically empty cluster, which is output from the Gardener service, Gardener layer. You have only empty Kubernetes cluster, which is pretty basic stuff, but you also need these additional software tools because every application needs this stuff. Yeah. You know better than me. Okay, and you can also have these ready-made services like, for example, Kafka, PostgreSQL. These are basically, again, just Kubernetes operators, but they are really refined. Yeah, so in a way that you can deploy these services in a highly available mode. You don't need to take care about it by yourself. You are just consuming it and use it, yeah. And of course, there is also defined backup and restore procedure. There is everything that you might need of it, yeah. So you can just use it like Lego bricks, and you can build anything out of it by yourself, yeah. So this is pretty cool stuff. And this is how this Kyma dashboard looks like. So there is also this nice web application where you can manage all of your additional software. And you can also see here directly this service catalog where you can have many ready-made services ready for deployment with a single click, or with single YAML, and via automation pipeline, you can just integrate it into your application deployment and deploy it entirely automatically. Okay, so I just went through entire platform. So now we have complete cloud-native platform where we can do all stuff that we would like to do. And now we have one very, very cool thing on top of it, yeah, which is, we are calling it confidential computing, or let's start with confidentiality challenges. So, of course, everybody would like to have a very, very secure environment where everything is encrypted. We can all tell stories about security guys that we are working with. They are pushing hard in this direction. You have to encrypt really everything. You have to encrypt network communication, you have to encrypt storage and data, because usually all business data or application data or some kind of this stuff is confidential. It might contain private data, yeah, which is protected by law. It might contain business data, which is again some kind of business secret, yeah. So you have to encrypt everything, but generally it's widely known that you cannot encrypt memory context. You cannot encrypt container running on your computer in the memory. You can, for example, create a snapshot of running virtual machine, and this snapshot also includes snapshot of your memory. In memory, you can see everything, your application, all of your security keys, encryption keys. There are hacker tools available publicly on internet, which you can use to find encryption keys directly in the memory, and it's just a matter of seconds to find these keys in memory context of any virtual machine. So it's really easy to break into some application or into some encrypted communication if you can get this snapshot of the virtual machine. So it means that all of the employees of the cloud operator, which has administrator rights, can do these snapshots on the background, and they can steal your encryption keys and use them for some malicious activities, or sell them on the internet or whatever, yeah? So this is not good, yeah? So we've been thinking about possible solution for this, and we have found one. It means that we are able now, thanks to recent technologies and technology development, we are able to encrypt also memory context, and we are able to encrypt entire container in the memory. So it means that if you will make snapshot of container or underlying virtual machine, then you can only see entirely encrypted memory context, and you cannot steal any data out of it, yeah? So we are calling it like secure or secured container. Yeah, and I will explain a little bit more about it, how it works now on 2 slides. Okay, so it works like you have your deployment pipeline and you are building your application with some image or some container, and it's not encrypted by default. You know, it's just standard process. Then we can take your image and just inject there some encryption libraries directly into image, yeah? And these libraries will be loaded together with your application when it started, and entire memory context will be encrypted automatically and transparently. So you don't need to, yeah, in 99% cases, you don't need to change you don't need to change your application or do this support for this encryption by yourself. You can just use this service and create this secured container, which can be also deployed again on this entire platform, on the Kubernetes environment, and it's running completely encrypted in the memory. And it's using technology directly in CPUs, in modern CPUs, which is called SGX. Yeah, it's one of the features of the Intel CPUs, it's a security encryption feature. Yeah, and this CPU is then able to encrypt or decrypt memory context transparently and without any changes into your application, basically. Okay, so this is really cool stuff, and of course, together with encryption of the storage and encryption of the network communication, you have complete secure environment where everything is encrypted. Yeah. So thanks to this solution, you can reach level of security which was, unthinkable before, yeah, and you can run very sensitive applications in this kind of technology, like applications maybe for military or storing very sensitive data, like, for example, healthcare, where you have patient records, where you have your medical history. You can store it there without having a fear that it might be some kind of easily stolen or it can be some easily broken. Yeah. Okay, so generally I can say that according to current knowledge, we have found only very few applications or very few components which are not compatible with this technology, and we can say that maybe 99% of components or applications are compatible. For example, Java runtime environment is one of the compliant components, so it means that basically every Java application can be entirely encrypted and can run with support for this confidential computing. And yeah, maybe I just like to add, maybe there will be some question, okay, we are now encrypting memory, but where are the keys stored? Yeah, how they are protected? The keys can be stored with the hardware TPM module, which is again as a part of the hardware, and only customer could have access to partially to this TPM, and they can store encryption keys there themselves, and yeah, thanks to this, only they can access these security keys, and all of the containers will be encrypted by these keys. But we are also considering currently there is already, because technology is progressing, there is also purely software component which is more suitable for the cloud environment. So we are also considering usage of this software security module, and probably in some months, maybe 1 year or so, we are also going to have this possibility, and this will be not dependent on the hardware security modules, which is an advantage. Yeah, so just to summarize it a little bit, this confidential computing allows us to protect the entire environment end-to-end, and allow us to run very sensitive applications. And yeah, it's a really cool technology. And for future, it's very promising because it can also open cloud platforms to before unconsidered kind of deployments, like, as I said, for military, healthcare, and so on. Yeah. So this was always a place for on-premise, very protected, highly secure systems. Currently, they can really consider to use cloud platform for this. But it has also some disadvantage. So I'd like just to state this disadvantage here. This disadvantage is that your provider cannot see your data because it's encrypted. So it means that provider could not help with many of the problems, could not help with troubleshoot because everything is encrypted. Yeah. So it means that this kind of service needs to be unmanaged. So it means that customer should take full responsibility about application or about resolving any of possible issues from this application workload. Yeah. So this is, it's something for something. So it has some advantages, but also this kind of disadvantage. Yeah, this is my last slide, and this is for you because most of you, or maybe all of you, are developers here. So this is just a short view how we are working internally and what kind of technologies we are using internally and how we are organized. Just few bullet points because it's not very complicated. We have separated a team or squad for each layer, like for infrastructure, for Gardener, for services, but also we are working together. We are having some regular meetings also together just to make sure that the entire platform will work as one. Yeah. Of course, each squad has its own architects. These architect guys are leading architecture, but it's not 100% like autocratic. Yeah, we are more like democratic, and architects are also, of course, listening to ideas of the members of the team. Everybody could come up with a good idea, and we might use it. Yeah. And we've got also cross-functional teams, or we are calling it communities, for example, for developing and maintaining pipeline, or for security themes or challenges, or for others. Yeah. Internally, we are using agile methodology. We are running in 2 weeks long sprints and then presenting results of the increment for everybody. So including some real life demonstration, we are showing results, and it's really transparent for everyone, even for management, which is also used to join these sessions and see by themselves from first hand how we are progressing. Yeah, and there are also some quarterly team face-to-face meetings because we are distributed team in many countries, and it's not very easy to meet face-to-face. We are working generally fully remote, but from time to time we are having this face-to-face meeting with some beer and discussing priorities for next quarter and resolving maybe some issues together. Yeah, and I really like culture in this team because I think culture is very important in every project, in every company, and I must say that I really like that there is a very good culture here. Everybody is listening to each other, and we are really working together and helping each other. On the right side of this slide, you can see technologies which are being used, or programming languages. Maybe most important or most widely used is Go language, which is, of course, very important because even Kubernetes is written in Go language, and all of these extensions, operators, and all of the stuff needs to be really written in Go language if we want to have it really efficient. And of course there is lots of shell programming because all of the automated pipelines and all of the support stuff. Yeah, there is also some C low-level programming in DPDK framework for network acceleration stuff on the infrastructure layer. There is, of course, some Python programming for some test frameworks and some support applications. We are even using our own customized Garden Linux distribution, which is based on Debian Linux, but it's a little bit customized, a little bit modified, not so much, but a little bit. And of course, we are using Git and GitLab. It is quite common nowadays, and also GitLab pipelines to automate builds and processes, and GitLab task management inside GitLab, like epics, stories, and everything. So that's all from me. Thank you very much for your attention.